In this next example, we're going to walk through a graph theory problem kind of from beginning to end. So we're going to take a look at a problem scenario, we're going to come up with a graph that models it, and then from that graph we're going to be able to answer the question being posed to us. So the floor plan of a 5-room house is shown. The rooms are labeled A, B, C, D, and E. The outside of the house is labeled F. The openings represent the doors. Now question, is it possible to walk through each room and the outside using each door exactly once? So in this problem, the rooms will be your vertices. Okay, your doors are going to be your edges. Okay, so the connections to the vertices. And then for this question, is it possible to walk through each room and the outside using each door exactly once? Okay, this is the same thing as you want to use each edge exactly once. Which means we're wondering, does the graph have an Euler path? Or possibly even an Euler circuit. Okay, but at the very least, we want to be able to use each door in this floor plan exactly once. Okay, so let's go ahead and draw a graph model of this. So each of the rooms are going to be a vertex. And maybe I'll put vertex F up here for the outside. I'll move this down just a little bit. Okay, so let's go ahead and draw in our connections. So A is connected to the outside, B is connected to the outside, C is connected to the outside, and it looks like B has another connection to the outside. Alright, so that takes care of these doors. Now let's take a look more in the interior. So A is connected to D, D is connected to B, B is connected to E, and E is connected to C. Alright, so I ended up with this funky graph model. So yours might look a little bit different than mine. The key thing is that you have the vertices A through F and that your graph expresses the same relationships. One of the ways to tell that is to make sure that you have the exact same number of edges and that the degree of all of your vertices match mine. So let's go through and find the degree of each vertex. A has degree 2, D has degree 2, F has degree 4, B has degree 4, E has degree 2, and C has degree 2. So if that's the case, then your graph and my graph represent the same scenario. Now in terms of answering this question, is it possible to walk through each room and the outside using each door exactly once? Yes, it is. This graph has an Euler circuit. So not only is it possible to use each door exactly once, it is possible to start and end at the same vertex as well, which is a much more restrictive condition. Let's go through here and state a possible route. So here is a possible Euler circuit. I'll go ahead and start on the outside. We'll enter room A first. I'll come in out with a different color. So we'll go from F to A. Then we'll go from A to D. We'll go from D to B. We'll go from B to E. From E to C. From C to F, or the outside. So at this point in time, then I would have to go from the outside back into B. and then from B back to the outside. So there is one possible circuit.